In the last session, we've started one topic that is various approaches of gastroretentive drug delivery system. So, in the last session, we have discussed one type or one approach that is a floating type gastroretentive drug delivery system. So, in the floating type, what happened that at the dosage form or the system, it will float on the stomach, or you can say it will be float on the GI fluid. So, the density of the system or density of the dosage form it should less than the gastric fluid. Okay, so the system or the dosage form it will float for a long time in the stomach, and the drug it will release in a controlled manner. There are then two types of floating system is there. One is an effervescent system and another one is a non-effervescent system. Okay, so in the effervescent system normally we use the effervescent components like sodium bicarbonate, tartaric acid, citric acid. So because of that effervescent component there is a release of carbon dioxide, or we can use some certain other type of substances or liquids which will convert it to gas in body temperature. And because of that gas generation or because of the release of the carbon dioxide, the system or the dosage form it will float in the gastric fluid. This is an effervescent system. Now coming to the second one, it is called the non-effervescent system. That will also an under floating type, but we are not using any effervescent components. Other than that we are using various method. So by using those method the system or the dosage form it will float on the GI fluid or in stomach. Okay, like suppose we are using or we are using a method or preparing sodium alginate or calcium alginate bits. Okay, so alginate bits is an one type. Then preparation of micro balloons, then using of any hydrophilic polymers to make an gel, means colloidal gel, hydrocolloidal gel, or suppose using a method by which we can make an microporous membrane system. So by using various method without using an effervescent components, we can prepare a system which will float in the gastric fluid or you can say in the stomach. Okay, now coming to the next topic or you can say the next approaches, that is an high density or sinking system. Okay, now in that high density on the sinking system, the name only it will implies that the system it will sink, it will not float. Then the uh, if we compare the first one or first approach, so it will not float but it will sink. Okay, it will sink is because of the high density. The density of the system or the density of the dosage form it will more than the gastric fluid. Okay, more than the gastric fluid. Normally we can make up to 1.5 to 2.4 gram per cubic centimeter. Okay, so the density is more than the gastric fluid, okay, or more than the stomach content. Okay, so how we can prepare or how we can formulate that type of system. So in that type of system we are using certain uh, compounds, so you can say the some certain substance which is having higher density. Okay, like zinc oxide or titanium oxide, barium sulfate. So what we'll do, we'll take the drug, then sorry, we take the core heavy core substance, then we'll coat with a drug. Suppose we have a drug like X. Okay, X, suppose take as a drug as an X. Okay, and we are taking a heavy core substance. Okay, heavy core substance whose density is more than the gastric fluid. Now we'll take the core and we'll coat the core with the X drug. Okay, then if we'll take that one, because of that higher density, that particular system it will sink in the stomach. Okay, it will not float. You can see in the diagram, so it will not float, it will sink. Okay, or we can do other things. We can take a particular substance which is having a higher density and mix with the drug. then we can make it as in form of a tablet. That system, if we'll take, it will go to the stomach and then it will sink in the bottom of the stomach. Okay, so by using a particular substance whose density is more, that particular substance we can take to prepare those high density system. Okay, it will sink in the stomach for long time and the drug will releasing in a controlled manner. Okay, so this system actually it is not suitable also, and it is not that much used to prepare and GRDDS system. It is not that much of use. Okay, high density or sinking system. Now coming to the next one, it is called the bioadhesive or mucoadhesive gastroretentive drug delivery system. Now I think this term is very familiar to you. That is a bioadhesive or mucoadhesive system. So those systems are mainly contain a particular bioadhesive polymers, the polymer which is having a particular character to adhere to the mucosal surface. Okay, so those are mucoadhesive or bioadhesive polymers, like chitosans are there, like gelatin is there, even some second generation polymers are there, like suppose an a thiomer is there. Okay, so various types of bioadhesive polymer, by using those we can prepare that particular system. Okay, now those polymer having tendency to adhere to the mucosal surface. Now there are various mechanisms are there. Okay, for this mucoadhesion. Okay, or you can say various theories are there which will support that mucoadhesion. Okay, the first one is an weighting theory. Now weighting theory is based on the ability of that bioadhesive polymer to spread and develop in contact between the system and the mucosal layer. Okay, weighting theory. So this is called the weighting theory. It based on the ability of the bioadhesive polymer, the bioadhesive polymer whichever we use in the formulation, or yeah, we use in the dosage form. So whenever you take that dosage form, the bioadhesive polymer, it will spread and contact properly or adhere properly with the mucus layer. Okay, next one, the diffusion theory. Diffusion theory is an uh, based on the ability of the polymers. Polymer means the biodesive polymer and the glycoprotein, the mucin, which is present in the mucosal layer. That two polymers or two proteins, the chains, the polymer chains. Whose polymer chains? The biodesive polymer and the mucin. So those chains, they will diffuse to each other, and they will, you can say, intermingles, and then it will entangles. Okay, the polymer chains, biodesive polymer and the polymer chain of the mucins, so they will diffuse to each other and they will intermingles and entangles, and because of that they tightly adhere to each other. Okay, so this is called the diffusion theory, where the polymer chain will diffuse, okay, to each other. The next one is then adsorption theory. So adsorption theory is based on the secondary force like van der Waals force and hydrogen bonding. So bonding between the biodesive polymer and the glycoprotein or mucin, which is present in the mucosal surface. Between them, there is an hydrogen bonding or any secondary force like van der Waals force. Next is then electron theory. So electron theory is an theory is based on the attractive electrostatic force between the glycoprotein, means the mucin, which is present in the mucosal layer, and the bioadhesive material. Okay, the electrostatic force, attraction force between the mucin or glycoprotein, which is present in the mucosal layer, and the bioadhesive polymer. Between them, there is an attractive electrostatic force, and because of that they attract to each other and they bind. Okay, so these are the four theories. So this type of system or this type of dosage form contain an bioadhesive polymer. That is the most important part of this type of system, where you're using a bioadhesive polymer, and that polymer, it will adhere to or bind with the glycoprotein, mainly the mucins. Okay, it will bind with the mucin, and you can say that it will bind with the mucosal layer. Okay, the mucosal layer of the stomach. Okay, the mucosal layer of the stomach, you can see in the diagram that it will bind with the mucosal layer of the stomach for long period of time, and the drug, it will release from the system in a controlled manner. There are four theory which is supporting that mucoadhesion: weighting theory, diffusion theory, then adsorption theory, and electron theory. Okay, so these are the four theories. Now examples, already I said various examples, biodesic polymer like sodium alginate or chitosan are there, then dextrin is there. These are the uh, first generation. Second generation polymer also there, like thiomer is there, then lactins are there. Okay, so these are the example of biodesic polymer. Coming to the next one, it is called the inflatable gastrointestinal delivery system or inflatable type. So inflatable type, the meaning of that, there is an gas will generate or air will enter, okay, or air or gas will generate. Because of that, it will enlarge like a balloon, and because of that, it will float or it will stay in the stomach for a long time. So this is called that inflatable type. Okay, so how it is possible? It is possible by formulating a particular system by using an liquid ether or a particular liquid which will gasify at body temperature. Okay, and that type of liquid, it will packed in a particular chamber. Okay, so how you formulate? We'll prepare a small chamber. That chamber is normally the chamber is prepared by some uh, bioerodible polymers. Okay, bioerodible polymers. So one chamber is there. That chamber is containing a drug reservoir and a particular liquid which will gasify at body temperature. Now the total chamber, okay, will packed in a capsule. Okay, so a capsule, inside it's contain a closed chamber. That chamber is containing the drug and a liquid which will gasify in presence of, or at, you can say, at body temperature. Okay, now that capsule, whenever will take, once it will go to the stomach, the capsule shell, which is made up of gelatin, it will get soluble. Okay, it will degrade and then it will get soluble. Then the chamber which was there inside that capsule, it will expose to that GI fluid. Okay, and the liquid which is present inside the chamber, it will convert it to gas because of that body temperature. Now once the system is having that gas, it will convert it in a large chamber, because inside there is gas is present, and because of that it's converted to a large system which will try to float in that gastric fluid. Okay, so this is an inflatable system. It's contain drug and liquid which will gasify in body temperature. So the total chamber, normally it will encapsulated in a capsule shell. Okay, or you can say that gelatin capsule. Okay, once we'll take the gelatin shell, it will get degrade or dissolve. Then the chamber, it will expose to GI fluid or gastric fluid in the stomach. Then the liquid is converted to gas. The total system, it will little bit enlarge because gas will be present inside, and it will try to float. Okay, and because of that, it will retain in the stomach for long period of time. Okay, and the drug, it will release in a controlled manner. Okay, so this is an inflatable system. Coming to the next one or last one, it is called that swellable GRDDS. Okay, so swellable GRDDS is very simple. We are using a particular type of polymer which will get swell or enlarge in presence of the gastric fluid. So it's very simple. We'll take the drug and an hydrophilic polymer, then that particular dosage form or the tablet, whenever it will take, as the system it will come in contact with the GI fluid, the polymer it will try to enlarge. Okay, it will swell that much that it will retain in the stomach and it will not exit from the pylorus. Okay, it will retain in the stomach, it can't pass or exit from the pylorus, it will retain in the stomach. So that's why it is also called as a plug type system, because it will get locked or just it can't exit, it will be completely locked in that stomach, or you can say in the pyloric sphincter. It can't exit from the pyloric sphincter, it will just lock or it will retain in the stomach because of its expandable size. Okay, so this is an swellable GRDDS. You can call it an swellable type or you can call it as an expandable type GRDDS. Okay, so these are the various approaches of GRDDS. So we have discussed about the floating type, okay, where it will be float. Then we'll discuss about the high density type or sinking system. Then we discuss about the bioadhesive type. Then we discussed about the inflatable type, and last we discussed about the swellable GRDDS. Okay, thank you.